Hi everybody. So for today we are going to learn how to solve quadratics by completing the square. So in order to do that I just need to recall some factoring. So let's solve the following by factoring. That's if it's factorable. So let's take a look here. There's no GCF, so I cannot take out a GCF. So I'm looking for two numbers that add to positive 10 and multiply to a negative 11. So if I think of the factors of 11, it just have 1 times 11. Those are the only factors. If I have to multiply to a negative, that means the signs are different. But if I add to a positive, that means the larger one is positive and the smaller one is negative. Now, if I combine a negative 1 and a positive 11, do I get a positive 10? I do. So those are the factors that I'm going to use here. So I get x minus 1 and x plus 11. And now to finish solving, I set each one equal to 0. So I get x equals 1 and x equals negative 11. And you can always plug it back in and check, but these are my final answers. Now remember, this is where it's equal to 0, where the whole graph, where our y is equal to 0. So that's really, if I were to think about where that happens on the graph, that means it looks something like this. And how do I know it looks something like this? Because it's a positive x squared, and here would be a positive 1, and here would be a negative 11. Those are my roots. So those are my roots here, okay? Or they're the, if I solve, those are the solutions of this equation. Another word we say is roots, zeros, or solutions. Those are all the same words that we could use here. So let's try number 2. Again, there's no GCF. I have to see what adds to this and multiplies to that. So I give it a try. It's 1 times 7. There's no other factors here. So if they have to multiply to a positive, they have to be the same sign. But if they add to a negative 12, that means they both have to be negative. So if I combine these two, negative 1 and negative 7, do I get negative 12? No. So this one actually is not factorable. So this is not factorable, but if I actually go into my calculator and I go into the y equals and I put x squared minus 12x plus 7 and then I graph it, I actually do get a graph that crosses the x-axis. Now, I'm going to actually just sketch it for you so it looks something like this when I graph it. And this is a very zoomed out picture of it. But it looks like this. That's what the graph looks like. So there are roots, but we don't know what those numbers are. So that is why we need to learn how to complete the square. Because if we learn how to complete the square, we could find out what those roots are. They might not be, a whole number or, an integer. It might be an irrational number. So that's why we learn this process. So let's try and understand what it means to complete the square. In order to do that, I need to know what square trinomials look like. So if I'm going to take the time to actually multiply these out, so I want to show you what they will be. So when I multiply them out, this is what I get. Now, if you take a look, my A term is 1, my B term is negative 4, and my C term is 4. My A term is 1, my B is positive 10, and my C term is 25. Here my A term is 1, my B term is negative 18, and my C term is 81. Now, all three of these are perfect square trinomials because it comes from a single binomial being squared. Now, I want to see if we can recognize a pattern. If I had x minus 2 being squared, my B term was negative 4, my C term is 4. When I had a positive plus 5, I had a 10 and a 25. When I had a negative 9, I had negative 18 and positive 81. So some of you might recognize the pattern here. The pattern is if I had, this is negative 2 plus negative 2. And this one is negative 2 times negative 2. Same thing here. This is 5 plus 5. And this is 5 times 5. And this is negative 9 plus negative 9. And this is negative 9 times negative 9. So that will always happen if I have a perfect square trinomial. So let's just say these are perfect square trinomials right here. So I want to find out what number has to be in that blank so that this is a perfect square trinomial. So think about it. This number has to be something plus something, where it's the same number. And this has to be whatever that is times itself. So what number goes there? 2 plus 2 is 4. So 2 times 2 is also 4. So the factored form is what squared? X, and we had positive 2. So let's try this again. I'm going to try it with this one down here. What plus what, and it has to be the same number, gives me negative 12. And then here I have to do that times itself. So if I take 12, I think about what number at plus itself, so I have to divide it by 2. What do I get? Negative 6 plus negative 6 is negative 12. So negative 6 times negative 6 is positive 36. So this is x minus 6 squared. So hopefully you're seeing how to find out what that c term needs to be so that we have a perfect square trinomial. So here this is going to be 5 plus 5. So here 5 times 5 is 25. So this is x plus 5 squared. Same thing here, x, oops. This is 7 plus 7. So 7 times 7 is 49. So this is x plus 7 squared. So hopefully you're seeing the pattern because this is going to help you complete the square. So negative 4 times negative 4 is a positive 16. So this last c term will always be positive in a perfect square trinomial. And that number was negative 4. And here, negative 1 plus negative 1. So negative 1 times negative 1 is a positive 1. So this is x minus 1 squared. So now we have written these as perfect square trinomials and wrote them in factored form, which is perfect. If you understand this, completing the square is going to be a piece of cake. So now another nice thing about completing the square, or the process that we just did, being able to get this perfect square trinomial, it actually helps us in writing the quadratic equation from standard form into vertex form. So if you look at this, this is written in standard form. If I asked you right now to sketch this, tell me where the turning point is, you're going to have to do some math, right? But if I had it in vertex form, it's a little bit easier to sketch. So we're actually going to do use the process of perfect square trinomials to help us here. So the first step that you want to do is you always want to get the x's by themselves. So in order to do that, I'm going to subtract the 3. Okay, so when I subtract the 3, I get x squared plus 6x equals negative 3. Now, I want to try and make this a perfect square trinomial, right? But here's the thing, this is an equation. If I'm going to add a random number to this side, to keep the equation equal, I have to make sure I add that same number to this side. So let's figure out what that number has to be. For this to be a perfect square trinomial, I need to ask myself, what number plus itself gives me 6? That's going to be 3 plus 3. So in this, I have to do 3 times 3, which is 9. Now, if I'm going to add 9 on the left side, I have to add 9 on the right. And then keep going here. So now write this in factored form. In factored form, this becomes x plus, remember, it's whatever number we used, 3 squared equals a negative 3 plus 9 equals positive 6. So this is pretty much almost in vertex form. If I subtract that 6 over, now I have it in vertex form. Now I know my vertex, or my turning point, is at negative 3, negative 6. But really, the important piece right now is that you know how to get up to here. If you know how to get up to here, then you're in good hands. Then you are ready to solve. So I'm going to do the remaining 2, and I want you to see how they turn out. Or maybe if you want to pause the video and try it yourself, just try numbers 2 and 3, get them into vertex form, see if you can do it, and then come back and check what I get. So as you can see, I've now rewritten numbers 2 and 3 into vertex form. I followed the same process every time. Again, I told you for completing the square when you're solving, you really only need to know up to here, this step. Okay? So this is really what you need to know how to do up to in order to solve by completing the square. So let's try this first problem. Now this first problem should look familiar because this first problem is the same first problem we had here. So if you notice, our answers were 1 and negative 11, but this we solved by factoring. Let's see if we can get those same 2 answers by completing the square here. So follow my steps. Again, the first step here is to leave this by itself. So to do that, I need to add over 11. Okay, so I get x squared plus 10x equals 11. Now I'm going to find out what c term here would make it a perfect square trinomial. But remember, if I add on the left, I have to add on the right. So thinking about this, I need 5 plus 5. So here I need 5 times 5, which is 25. So if I were to write it in factored form, this is x plus 5 squared equals 36. Now, this is where the process changes because we're not trying to get in vertex form, we're trying to solve here. So I'm actually going to change color so you can see now how do we solve it. If I'm trying to get x by itself, I need to get rid of the squared first. I need to work from my outer layers in. So how do I get rid of a squared? I have to square root. Now, remember, we've learned this in the past. When I square root, a square root I have to put plus or minus, a positive or a negative. So here, a square root and a squared canceled out. I'm just left with x plus 5 equals. Now, is there a square root of 36? Yes, it is 6. So my answer here is either positive or negative 6. Now my last step here to get x alone is to subtract 5. So here, if I want to, I'm going to keep solving this. If I want to subtract 5, that means I get x equals. Now, you could write it either way. You could say it's a positive or negative 6 minus 5, but more commonly, do we write the negative 5 first plus or minus 6? Now, remember, what does that mean? That means I have 2 answers. My 2 answers is, one of them is negative 5 plus 6, and the other answer is negative 5 minus 6. That's what plus or minus means. So what does negative 5 plus 6 equal? 1. And negative 5 minus 6 equals negative 11. Hold on, wait. Are those the 2 answers we got earlier? 1 and negative 11? Yes, they are. So notice, it's a different process, but we still got the same answers here. By completing, this is called solving by completing the square. Okay? So let's try another example. So if you remember number 2 from the do now, Number 2 from the do now was not factorable, but we knew there were roots. We just didn't know what they were. So now let's try and complete the square. So again, I'm going to follow those same exact steps. So if you want to see, I'm going to follow the same steps by leaving this by itself. So first thing I have to do is subtract over the 7. Okay. So I get x squared minus 12x equals negative 7. Then I need to get this blank. I need to think about what goes into that blank to make it a perfect square trinomial. So negative 6 plus negative 6 is negative 12. So negative 6 times negative 6 is a positive 36. So now if we continue here, read the factored form is x minus 6 squared equals 36 minus 7 equals 29, or negative 7 plus 36 is 29, either way. And now let me finish solving here. So watch what happens. I need to get rid of the squared, so I have to square root. When I square root, I have to put plus or minus. Now I get x minus 6 equals positive or negative. Now there is no square root of 29, so I'm going to leave it as the square root of 29. Okay? Now you could always ask yourself, can I simplify it? You probably can or cannot. Sometimes you can, sometimes you can't. In this case, we actually can't simplify the 29, so it stays as the square root of 29, but sometimes you can. But for now, let's just focus on the work. So now my last step is I have to add 6. So I get, let me keep going, I get that, hold on, let me see if I can make this a little bit smaller so I have just about more room. X equals, now remember, what's common is to put the plus or minus after. So I have a positive 6 plus or minus the square root of 29. So what does that mean my two answers are? My two answers are 6, x equals 6 plus the square root of 29, and x equals 6 minus the square root of 29. Let's just see about, these are my final answers because I can't combine them. So those are my two answers, but let's just see about how much. So in the calculator right now, I'm doing 6 plus the square root of 29, and I get 11.385. And then 6 minus the square root of 29 is 0.614, but really I'm going to round it to 5. So really, if you pay attention, because these are both irrational numbers, it's about, 0.6 and 11.3 or 0.4. Now, if you look back at my sketch, that kind of makes sense because in the graph, there was one really close and there was one a lot further away, but they were irrational numbers. So that's why even though it wasn't factorable, it still had roots. So this is how you solve for the roots by completing the square. So if you would like, there are 6 more problems I'd like you to try on your own. So pause the video here, come back and check your answers, check your work. I'll have it all available for you. Good luck. Okay, so here are the remaining answers. I did say there were 6 more questions, but I happened to notice number 7 and 8 were accidentally a repeat of questions 5 and 6. May have been just a typo. So it kind of saved you 2 extra questions to do. So I'm going to actually just zoom in to these questions, and I'm going to let you look at the work, pause it when you need to, so that you could check your answers. So number 3, the answers were 3 and negative 17. Number 4 were 3 and negative 1. Number 5 is negative 7 plus the square root of 97, and negative 7 minus the square root of 97. And then number 6 was negative 3 plus the square root of 58, and negative 3 minus the square root of 58. Now I just want to let you know, again, if you can reduce it to, you could try. If your answers are multiple choice, you could always just compare. Worst case scenario, if you don't know how to reduce the radicals, you can leave it like this, and you may lose only 1 point for not being able to simplify the radicals. So if you have any questions, make sure you reach out to me, and have a great day, everybody.